Operators are used to perform operations on variables and values. So we have many types of operators and they are divided into categories. So first is arithmetic operators. So this includes plus, minus, multiply, divide, floor division, exponentiation, and modulus. Next is assignment operator. So it includes equals to, plus equals to, minus equals to, multiply equals to. Third is comparison operators. So it includes double equals to, then not equals to, less than, greater than equals to, less than equals to. Next is logical operators. So these are and, or, not, all in small letters. Then we have identity operators, which are is not. Then we have bitwise operator, and, or, then left shift, right shift, and we have many more operators. Now let's check the functioning of the operators. So here's a variable x with value, let's say 5. Now we will check following operators. We will also print. So first operator is plus. So let's say x plus 2. It should print 5 plus 2, 7. Then next operator is minus, and let's say 3. Then 5 minus 3 equals. Then we have multiply. So 5 multiplied 2 is 10. And then we have divide. So let's say to make it easy, we can use x value as 6. 6 plus 2 is 8. 6 minus 3 is 3. 6 multiplied 2 is 12. And 6 divided by 2 is 3. Then we have exponential. So we can say 6 to the power, let's say 2. So it will be 6 multiply 6, which will be 36. And then let's say there is a variable y with value, say, an odd number. So now we have one more arithmetic operator, which is floor division, and it is represented by double slash, or maybe we can say double division, like we have single slash here. So let's say by 2, and to check this value we can have one more y divided by 2. So this will print 5 divided by 2 will be 2.5, but floor division will be 2 only. So it will always return the integer. So now let's run this program and check these output. Yeah. So for first we have 8, then next is 3, then 12, then 3 and 36. So here 3.0 and 36. So here we can see for division, it will always return the floating value, whether it is completed uh, completed divisible by 2 or not. It will always return the floating value. Then we have exponential 6 to the power 2, which is 36. Then we have next variable is y equals to 5. Then y divided by 2 is 2.5. And then this is floor division. So 5 floor division 2 is 2. And there is one more, modulus. So y modulus 2. So this will always return the remainder. So when 5 is divided by 2, 1 is the remainder. So let's run it again and check the last value. Yeah, so it is 1. And if we, let's say y is 13 and we divide it by 10, then the remainder will be 3. So let's remove this. So the last value is 3. Now we will see the next type of operators, which are assignment operators. So assignment operator includes equals to, plus equals to, minus equals to, multiply equals to. Let's say x is 2, then if we do x plus equals to 3, okay, so we will first print the value of x, which should be 2. Then we have used the second operator, x plus equals to 3. So x plus equals to 3 is equivalent to x equals to x plus 3. So here it will become x equals to 2 plus 3, which is equals to 5. Next is, now we will print this value, print x. Now next is x minus equals to, let's say 1. So now here the value of x will be 5. So now x minus equals to 1 is equivalent to x equals to x minus 1, which will be x equals to, now the value of x will be 5 minus 1, which is equals to 4. So if we print the value of x here, it will be 4. Now next is x equals to, no, x multiply equals to, let's say 4. So this is equivalent to, sorry, x equals to x multiply 4, which will be x equals to, so here the value of x will be 4. So 4 multiplied by 4, which is equals to 16. So we print the value of x here, it will be 16. So let's check these outputs. Run the program. So we have first is 2. So this is equals to operator. So x equals to 2. Two values assigned to x. And then we have printed the value of x. It is 2. The next is plus equals to operator. So for that, this 3 will be added to the current value of x, which is 2. So 2 plus 3 will be 5. So we have 5. And next is minus equals to. So 1 will be subtracted from the current value of x. So current value of x is 5. So 5 minus 1 will be 4. So this is the 4. And then we have multiply equals to. So current value will be multiplied by 4. Current value is 4. So 4 multiplied by 4 is 16. Hence we get 16. So these are the assignment operators. Now we will talk about comparison operators. Example of comparison operators will be double equals to, not equals to, then less than, greater than, then we have greater than equals to, and less than equals to. Let's say we have value of x as 5. Now we will print x equals 5. So since the value of x is 5, so this is an assignment operator. We are assigning 5 value to the variable x. And here double equals to is comparison operator. Here we are comparing the value of x with this value. So we have value of x as 5. So 5 equals 5, which will be true. Hence, the output of this statement will be true. Now if we write x equals 3, so the output of this statement will be false because x is 5 and not 3. Now check the other statement. If x is not equals to 3, yes, so this will be true because 5 is not equals to 3. Then we have greater than symbol. So value of x is 5. So if x is greater than 4, it will be true because 5 is greater than 4. And for the negative case, we can check if x is greater than 6, it will be false because 5 is less than 6. So now let's check the less than symbol. So if x is less than 6, it will be true because 5 is less than 6. Then we have for the negative case, we can, let's say x is less than 4. Here it will return false because 5 is not less than 4, 5 is greater than 4. So let's run this program and let's see these operators, assignment operators. We have true, false, true, true, false, true, false. Here also we have true, false, true, true, false, true, false. So now the remaining operator is greater than equals to and less than equals to. So let's check those as well. So I will write at the top and we can see the top entries. So print if x, that is 5, is greater than equals to 5. For, I will remove this because we have already tested. Now we will check this. So 5 is greater than equals to 5. 5 is not greater than, but it is equals to 5. Hence it will be true. Now print x is greater than equals to 3. That means is 5 greater than equals to 3? So it is not equals to 3, but it is greater than 3. Hence this condition will be true. Now print x is greater than equals to 6. So x is less than 6 and x is not equals to 6. Therefore, this condition will be false. So let's run this and check. We have true, true and false. So now let's check less than symbol. So similarly we will check. So if I update it, so is 5 less than equals to 5? So 5 is not less than 5, but 5 is equals to 5. Hence one condition is true. Therefore it will return true. Is 5 less than equals to 3? So 5 is not less than equals to 3 and 5 is also not equals to 3. Hence this will become false. Let's update this symbol as well. Is 5 less than equals to 6? Yes, 5 is less than 6, but it is not equals to 6. So one condition is true, therefore this will return true. Let's run this program. So here we can see true, false and true. Now let's move to other operators. Next will be logical operator. Logical operators. So example of logical operators are and, or, not. So for logical operators, to test it, we can say let's say x equals to 5. So now we will test the logical operators with value 5. So I will write print x is greater than 4 and x is less than 6. So here, so basically it is asking for simplifying the chain comparison, and if I click on it, it will just remove this AND operator, which we don't want to remove here. So now let's understand this. So we are checking if 5 is greater than 4 and so this is logical operator, and then we are checking if 5 is less than 6. So for AND operator, both the conditions should have to be true. So here 5 is greater than 4. Yes. So this condition is true. And we have x is less than 6, that is 5 is less than 6. Yes. We have both the conditions as true. Therefore, we will get the result as true. Now let's check the negative condition. If x is greater than 4 and x is less than 3. So here first condition will be 5 is greater than 4, true, and 5 is less than 3, so this will be false. Now out of two conditions, one is false, therefore in AND operator, if any of the condition is false, it will get the result as false. Now if I write x is greater than 6 and x is less than 6. So here 5 is greater than 6. So this condition is false, and 5 is less than 6. So this condition is true. So out of these two conditions, one is false. Therefore, output will also be false. Now let's check that. So we get true, false, and false. Now let's change this AND operator with OR operator. So for OR operator, if any of the condition is true, it will return true. For first, if x is greater than 4, we have true, then we have OR, and then we have again true. So both the conditions are true, therefore we have true. It will return true. Now let's update this. So now first condition is true, and then we have OR operator. Then second condition is false. So for OR operator, if any of the condition is true, it will return true. So here we will get true. Update this and with OR here also. So here one of the condition is true, therefore it will return true. Now if all the conditions are false, then OR operator will return false. So if x is greater than 6 or x is less than 3. So for first condition, 5 is greater than 6, false. And second condition will return 5 is less than 3, false. So here we have both the conditions as false. Therefore, OR operator will return false. Now let's run this program, and we get true, 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 and false, like we have here. Now next is NOT operator. So NOT operator will just invert the output of the current condition. So current condition we have this, and its output is true. If we apply not to this condition, its output will get changed to false. It will be inverted. If it is true, it will get false. If it is false, it will get true. So let's write not operator and move this condition to bracket or parenthesis. So here we can write not true, and it will be not true, which will return false. Now let's add not here also. So it will be not true. So this will become false. Let's add not here. So this is just the comment, and it has nothing to do with the output. This is just to make this code understandable. After simplifying, we will get not true, which is inversion of the true, which is false. Now we have not here, not false. Now inversion of false will be true. Now let's run this program and check the output. So here we have false, 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 then true. So that's it about the logical operators. Now the next is identity operators. Example of identity operators are is not. Let's check the examples. First variable is x equals to, let's say, 5. Then y equals to, again, 5. So both of these variables are pointing to same data. So this 5 will be present in a memory location and x and y are pointing to the same memory location. And then let's say we have another variable which is pointing to some other memory location whose value is 2. If we check if x is y, basically is operator will not match or will not check the values of these variables, but it will check whether they are pointing to same memory location or the same value or not, but it will not check the value. So x is y, yes, because x and y, they are both pointing to same memory location whose value is 5. It will be true. Then if x is z, since x is pointing to 5 and z is pointing to 2, therefore, and these two 5 and 2 values are at different memory locations. Therefore, if we try to print x is z, so it will print false. And similarly, if we try to print, let's say, the reverse of it, if z is x, z is x, then also we will get the same result. Let's run this program. We have true, false, and false. So now next is not operator. So basically is not operator is the inverse of this. So it will, so whatever the output of is operator, is not operator will just inverse the result. So here x is y is true. If I type x is not y, so it will just inverse the result. So it will be false. So if I type x is not z, then it will inverse the result. It will print true. Similarly, here also it will print true. Now let's run this program. So here you can see false, true, and true. So this is all about the identity operators. The next is bitwise operator. We have AND operator, we have OR operator, we have left shift, then we have right shift. So in order to understand bitwise operator, we must first understand the binary values of a decimal value. So let's say we have 2. So in binary, let's say of 8 bits, it will be represented as like this. And for 8 bits, so this bit will represent 1, and let's say this will represent 1. This represents the value 2. Then this value, I mean, it will be like 1, 2, then 8, then sorry, it will be 4 multiple of 2. Then we will be having 8, then 16, 32, and so on. So if I talk about 2, so here we have 2 at the second position. So it will be 1 and rest other will be 0. So if we talk about, let's say, okay, let's go with 2 only. So x equals to 2 and make it as comment. So it will be, let's say, multi-line comment. So let's say x equals to 2. So print x and 1. So for 1, 1 will be 0, 0, 0, 0, 0, 0, 0, 1, because 1 is at the last place and rest all bits will be 0. So if we do AND operation, so AND operation will be we will check bit by bit. So first is 0 and here we have 1. So AND operator, in AND operator only the output will be 1 only, and only if we have 1 at both the places. Otherwise it will be 0. So 0, it will be 0 for if we have 0 0 or 0 1 or 1 0. The output will be 0. But if we have 1 and 1, then output will be 1. So if I type x and 1, so x is 2. So here we will be having 0 and 1, which is 0. Then 1 and 0 also 0, and rest all are 0. Therefore output will be 0 zeros, and 0 will represent the value, decimal value, as 0. So it will print 0. Now let's print x and 3. So x is 2. So I will type 3 here. So for 3, it will be 2 plus 1, 3. Therefore, last bit and second last bit will be 1 and rest other will be 0. So now we need to check these two values. So 0 and 1 will be 0, 1 and 1 will be 1, and rest other will be 0. So for this, if I do 2 and 3, then I will get the output as 0 0 0 0, then 0 0, and for this it will be 1, and then for the last one is 0. Therefore this will represent the number 2 in the decimal format. So it will return 2. Now let's run this program. For the first we have 0, and for the next we have 2. This is about the AND operator. Now let's check the OR operator. Here I will just update the AND symbol with OR symbol. So this is pipe symbol, which here in Python represents OR operator. So in OR operator, if any of the bit is 1, it will be represented as 1. So if I talk about x or 1, x is 2, therefore we will see these two values only, the binary ones. So 0 and 1 will be 1. It will be 1. Then second will be 1 and 0. So it will be 1 and 0, it will be 1. And rest are zeros. So 0 and 0 will be 0. This will be the result. Now it will get converted to decimal number. So to convert the binary to decimal, we will use this. So here it will be 2 and it will be 1. So 2 plus 1 will be 3 and rest are 0. So output will be 3. Now next is 2 or 3. So basically 2 or 3. So we will check these two binary numbers. So 1 and 0. So any of the digit is 1, then it will be 1. So here the output will be 1. Here, so output will be 1. And then for x 2 and 3 we are checking, then 1 and 1 it will be 1. It will be 1. And then for rest it will be 0. Remove the space here. So it will be again 3. Let's run this program. So here we have the output as 3. We have covered the OR operator. Next is left shift. We'll remove this. It will be left shift. And by how many places? Let's say 2 places. X is 2. So these bits will get shifted. So these last 2 bits will be ignored and these bits will be shifted 2 places to the left, and new bits will be added from the right, and those will be 0 only. So therefore output of this x equals to 2, and with a left shift of 2 places it will be, so 2 0 0 will be added in the AND. Then we have 0 1 0 1, and then rest all are 0, and last two 0 0 will be ignored. So this will be the output. Now let's convert it to decimal number. So we have 1 2 3 4. At fourth place we have 1. So 1 2 3 4. So this represents 8. So here the output will be 8. Let's run this program. So here you can see the output is 8. So similarly, if we shift, use the right shift with 2 places, but so we don't have, it will be 0. So let's say right shift with 1 place. So if we right shift this, so this 0 will get ignored, this 1 will shift here, and all these zeros will be shifted towards right, and in the end we'll be having one more 0. So we'll be having only 1 at the last. Rest others will be 0 because we are shifting these numbers to right with for only one place. This will be the output, and if we convert that to decimal number using this, so it will be 1 because 1 is present only the last at the last. Last represents the 1 value. So let's run this program. So we have 1. So this is all about the bitwise operators.